For millennia, humanity was aware of only a few planets in our solar system: Mercury, Venus, Mars, Jupiter, and Saturn. These celestial bodies were observable with primitive telescopes and even the naked eye under favorable visibility. However, in the late 18th century, the distinguished astronomer Sir William Herschel made a significant discovery, finding a completely new planet with an icy bluish tint. Initially, this celestial body was mistakenly identified as a star, but it was later realized to be a full-fledged planet. Today, we know it as Uranus, a gas giant located at a distance more than 19 times Earth's distance from the Sun. This immense remoteness means that Uranus takes a full 84 Earth years to complete one orbit around our system's central star. In addition, the aforementioned astronomer contributed to the study of space by discovering many other notable objects, including double stars and nebulae. In the mid-1840s, astronomers noticed anomalies in Uranus's movement. Something was gravitationally affecting the planet, distorting its orbit in an unusual manner. Based on these observations, the hypothesis of another unknown planet was put forward. Using complex mathematical calculations, they were able to predict its possible location. Consequently, in 1846, Neptune was discovered with a telescope. This planet proved too dim to be observed with the naked eye, a fact explained by its colossal distance from the Sun. This discovery caused extraordinary excitement in the scientific community. One can only wonder how many more planets might be hidden in the fathomless darkness of our vast solar system. Also, in the mid-1840s, astronomers observed something extraordinary happening in the celestial sphere. Mercury, a small rocky planet, exhibited strange behavior. Its orbit deviated from its predicted trajectory, causing bewilderment. Among the researchers was a brilliant French scientist named Urbain Le Verrier. He proposed a theory about the potential existence of another planet in our solar system that had remained undiscovered until then. According to his hypothesis, it should have been located somewhere between Mercury's orbit and the Sun. This hypothesized planet, which he named Vulcan after the ancient Roman god of fire, he believed would have an incredibly superheated surface and could explain Mercury's inexplicable behavior. Although Le Verrier never definitively claimed that Vulcan was the sole cause of Mercury's orbital perturbations, astronomers worldwide, enthusiastic about the possibility of discovering a new celestial body, embraced the idea of Vulcan as a real planet, which, as it turned out, did not exist. People diligently dedicated themselves to developing ideas and gathering information about it. Some scientists doubted the likelihood that they could have missed another planet comparable in size to Mercury. By then, detecting such a planet would have been extremely difficult. However, there remained a minuscule chance of a smaller celestial body existing within Mercury's orbit, one that would be too close to the Sun to be visible. One theory suggested it would be located approximately 13 million miles from the Sun. Mercury, though possessing the most eccentric orbit in our solar system, approaches the Sun at its closest point to about 28.5 million miles. This means Vulcan would have been less than half that distance. The theory also asserted that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its orbit would be inclined approximately 12 degrees relative to the orbital plane of the other planets in our solar system. Vulcan's position, even at its furthest point from the Sun, would still be too close to the luminary to be discernible with the naked eye, even at dusk. The only opportunity to see Vulcan would have been during a total solar eclipse, or when it transited directly across the Sun, which, according to the theory, should have occurred 2 to 4 times a year. Scientists hypothesized that this mysterious planet was located so close to the Sun that it could only be observed during a total solar eclipse when the Moon completely blocked the Sun's dazzling brilliance. Therefore, every time an eclipse occurred, researchers strained to catch a glimpse of Vulcan in the celestial body. They made immense efforts, but despite all their endeavors, they never succeeded in finding this enigmatic planet. Some astronomers claimed to have spotted it during eclipses, but no one was ever able to confirm these observations or provide irrefutable evidence. The theory of Vulcan's existence remained in limbo, awaiting more favorable conditions for verification. Einstein, however, had an entirely different concept. Everyone is well aware of his theory of general relativity, aren't they? In it, he postulated that gravity is not a fundamental force of nature, but rather a consequence of the curvature of the space-time continuum caused by the presence of massive cosmic objects such as planets and stars. Planets make their usual revolutions around the sun precisely because the space-time around it is curved. This means that celestial bodies are, in a sense, continuously falling towards our solar system's central star. And Einstein attempted to explain Mercury's unusual orbit by relying on his own theory of relativity. Unlike the orbits of other planets in our solar system, Mercury's trajectory was not perfectly circular. Instead, it seemed to wobble slightly, as if some invisible force was constantly deflecting it. Einstein proposed that this phenomenon might be due to our sun's colossal gravity warping the very fabric of space-time around it. He argued that this might have subtly altered Mercury's orbit. It took the scientific community some time to verify this theory, but it was ultimately recognized as the most plausible explanation for the observed anomalies. Despite Albert Einstein's theory offering a more elegant explanation for Mercury's unusual orbit, some scientists continued to harbor hope for the existence of the hypothetical planet Vulcan. Giving up on the idea of Vulcan was particularly difficult because Mercury is, moreover, an extremely challenging planet to observe from our perspective. Over time, however, an increasing number of researchers accepted Einstein's theory, preferring it over their own assumptions, and began conducting observations of total solar eclipses specifically to test Einstein's theory of relativity rather than searching for Vulcan. Vulcan is not the only hypothetical planet actively discussed in the modern era. Some scientists suggest that a mysterious planet might be hidden in the distant reaches of our solar system, and its existence appears quite probable. Although no one has directly observed it yet, computer modeling indicates that the so-called Planet 9, or Planet X, is likely somewhere beyond Neptune's orbit. In terms of size, Planet X might be comparable to Neptune. It could be 10 times as massive as Earth and orbits our Sun on an elongated path that is, on average, 20 times farther from the Sun than Neptune. A year on this planet could last anywhere from 10,000 to 20,000 Earth years. For comparison, a year on Neptune is 165 Earth years. The presence of such a massive object beyond Neptune could explain the unusual orbits of smaller bodies in the Kuiper Belt. The Kuiper Belt is a region of our solar system beyond Neptune, populated by numerous asteroids, comets, and other small objects, predominantly composed of ice. There was another hypothetical planet known as Nibiru. Many remember the rumors of a possible end of the world in 2012. One popular scenario was Nibiru, as some claimed, colliding with our home planet by the end of that year. Of course, nothing happened, and we are all still here, perfectly fine. However, the idea of Nibiru proved intriguing. Stories about it began circulating in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book The 12th Planet, claiming it orbited the Sun every 3,600 years. But there is no chance that a planet with such an eccentric orbit would not have gravitationally disrupted the orbits of other planets in our solar system. And if it truly were approaching Earth in 2012, it would have been visible to the naked eye. Simple calculations showed that Nibiru would have been almost as bright as Mars at its dimmest phase, and brighter than the dimmest stars observable from a city. Well, perhaps we'll have better luck in the next 3,500 years or so. In 2011, a comet named Elenian appeared, which many people mistakenly took for Nibiru. However, when observing comets and planets through a telescope, it becomes clear that they look different. A comet has a coma, which is a gaseous atmosphere, and a tail, something a planet does not have. Moreover, this comet did not collide with Earth. It came too close to our Sun and broke apart. The remaining fragments will continue their journey towards the outer solar system for the next 12,000 years. So perhaps we are nearing the discovery of a massive icy planet beyond Neptune's orbit. Yes, sorry Pluto, it's still not you. Recently, some maps of the universe, created using data from a telescope in Hawaii, have ruled out about 78% of the possible locations of this enigmatic Waldo of space. Some call it Planet 9, others prefer Planet X. In any case, its existence has been debated since it was first hypothesized, and this is mainly because no study has yet been able to answer the main question: does it actually exist? If discovered, Planet 9 would be the fifth largest planet in our solar system, with a mass 10 times that of Earth. It is also presumed to be gaseous, similar to Uranus. The initial Planet 9 study, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther than Neptune, which is about 2.8 billion miles away. As a result, Planet 9 would take anywhere from 10,000 to 20,000 years to complete one orbit around the Sun. If confirmed, this not yet fully understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but so far, without a single piece of evidence or observation to confirm them. Before dismissing this as a wild guess, it's important to note that these researchers relied on complex mathematical models and computer simulations to infer the planet's characteristics, as this is their area of expertise. The hypothetical presence of this mysterious celestial body, known as Planet 9, could shed light on a number of unexplained features observed beyond Neptune's orbit. This refers in particular to the Kuiper Belt, a vast donut-shaped region filled with icy debris left over from the initial stages of the solar system's formation. Among these fragments are comets and dwarf planets such as Pluto. Notably, the 6 most distant objects in the Kuiper Belt exhibit elliptical orbits that are remarkably aligned in the same physical direction and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What is particularly puzzling is that despite their varying orbital speeds around the Sun, they maintain this unusual alignment. The probability of such a consistent arrangement being a random coincidence is extremely low, approximately 0.007%. It is at this point that Planet 9 comes into play, a hypothetical massive celestial body that offers a compelling explanation for this strange phenomenon, potentially exerting a gravitational influence on the formation of these orbits. The initial theory, however, did not last long, facing accusations of observational bias and calculation errors. Then, in 2017, another study emerged, once again reviving the idea that perhaps Planet 9 does exist after all. Spanish astronomers employed a completely new approach, focusing their attention on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun on highly elongated elliptical paths with average distances exceeding 13 billion miles. The study suggests that the distances between the nodes of these objects and the Sun could provide a key to unlocking the location of Planet 9. You see, these nodes are critically important points where a celestial body's orbit crosses the plane of the solar system. When these objects reach these points, they are more likely to interact with other bodies in the solar system, potentially causing significant changes in their orbits, or even leading to collisions. Thus, if the trajectory of these extreme trans-Neptunian objects remains stable, it suggests that everything is in order. But if not, it serves as a clear indication that something else, something colossal, is interfering with their path. And that is precisely what the study discovered. There, unseen, something is knocking these objects off course, and this something could be a planet located 300 to 400 times farther from the Sun than Earth. To date, the study of extreme trans-Neptunian objects provides the most compelling evidence for the existence of Planet 9. And if you are still not convinced by this theory, know that similar strange movements have already led to the discovery of planets in the past. Neptune, for example, was discovered precisely because Uranus's movement did not quite match the predictions of Newtonian gravity. However, its orbital deviation could be explained if it was caused by the pull of an undiscovered planet. And that is how we discovered Neptune. It's 2021, and everyone is talking about Planet 9 again. After correcting some older assumptions, research now leans towards the idea that this mysterious world makes an epic revolution around the Sun every 7,000 years. This is huge news because it means this planet could be closer than we ever thought, making it significantly easier for our telescopes to detect. The article also suggests there's a colossal 99% chance that the peculiar orbits of these various objects are due to this invisible planet, and not just some cosmic coincidence. Now, the probability of this entire situation being a random occurrence has dropped to 1 in 250, which is much better than the 1 in 10,000 in 2016. All these optimistic figures have led us to where we are today, maintaining our hopes and working on improving equipment to continue the mission of detecting Planet 9. As mentioned earlier, researchers in Hawaii have created a sort of treasure map using a panoramic survey telescope and rapid response system to rule out 78% of its possible locations. This is excellent news considering how difficult it is to find a planet-sized needle in a cosmic haystack. But unfortunately, the presence of Planet 9 remains a phantom in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it's only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They are placing their hopes on the Vera C. Rubin Observatory, currently under construction in Chile and scheduled to begin scientific operations in late 2025. For 10 years, this observatory will scan the entire southern sky every few nights with a 27-foot fast-moving telescope equipped with the world's largest digital camera. The idea is to catalog everything in the solar system, reaching up to and beyond Neptune, and track the movements of millions of celestial objects, including space debris, asteroids, comets, and stars. If Planet 9 truly exists, this next-generation telescope might be the one to find it. The existence of this hypothetical planet, shrouded in mystery, is not universally accepted within the broader scientific community. The reason is simple. Planet 9 is not the only explanation for the anomalous phenomena occurring beyond Neptune's orbit. For example, one theory suggests that an entire collection of distant cosmic bodies, such as dwarf planets, comets, and moons, could collectively influence the orbits of the so-called extreme trans-Neptunian objects. Other researchers lean towards the idea that a black hole is behind it all. These incredibly compressed masses represent some of the densest objects in the universe, potentially capable of influencing the orbits of other celestial bodies, much like the enigmatic Planet 9, whose ghost haunts the minds of scientists, is hypothesized to affect them. Another bold and unconventional perspective suggests that our current understanding of the laws of gravity is flawed, or more precisely, incomplete. This theory, called modified Newtonian dynamics, MOND, hypothesizes that these distant icy objects exhibit their unusual behavior not due to the influence of another planet, but rather because they are affected by the colossal gravitational field of the entire Milky Way. However, even the most convinced proponents of this concept admit that it is still too early to draw definitive and firm conclusions, and much more extensive and in-depth research is required to confirm or refute this theory. Meanwhile, as we continue our unrelenting hunt for Planet 9, some astronomers have gone even further, proposing the existence of a hypothetical Planet 10. This world, if it exists, is presumed to have a mass and size comparable to Mars or Earth, and to be located at the very edge of the Kuiper Belt. The catch, however, is that if this presumed Planet 10 is indeed as small as scientists believe, it might simply not have enough gravitational force to clear its orbit of space debris. And this is quite similar to the situation that occurred with Pluto, which was one of the key reasons for its demotion to a dwarf planet back in 2006. So perhaps it's best not to get too worked up about this. This hypothetical Planet 10 might very well be classified as another dwarf planet. August 23, 2023. The day India's Chandrayaan-3 entered the annals of history, becoming the first to successfully land on the Moon's south pole, a place we typically don't see from Earth. What makes this lunar cache so appealing and fascinating to scientists? It turns out it hides something quite precious: lunar ice. It is believed that there is much more of this ice here than has been found in the northern regions, and it's not hard to see why scientists are so excited by this discovery. This is a potential source of frozen water that could become our key to establishing a permanent lunar settlement, or even to fueling future crewed missions to Mars. Scientists had known about the existence of this ice for over 2 decades, ever since a NASA spacecraft accidentally stumbled upon it during one of its missions. Then, in 2018, NASA triumphantly declared that they were 100% certain of the ice's presence. They announced that the moon's south pole is rich in water. Now, imagine, future lunar settlers could use this water supply. This could help us sustain life in the barren lunar landscape. Furthermore, by cleverly splitting water into oxygen and hydrogen, we could obtain both breathable air and rocket fuel. All these possibilities would make lunar missions more feasible and self-sufficient. It also opens up a stunning opportunity to look into the past. This ice, possibly as ancient as the moon itself, could reveal profound mysteries of both the moon and Earth. But, as it turns out, water is not rare in outer space at all. There could be many planets where life could thrive. We know this because we have started detecting water vapor around stars, and this water is strikingly similar in composition to the water in our own solar system. This discovery suggests that Earth's water originally came from space. Water forms around stars in a cloud of extremely hot vapor, then turns into ice and adheres to tiny dust particles. These particles clump together over time and become larger objects, such as comets, planets, and other celestial bodies. Some of them become comets and planets in our own solar system, and this is how water spreads throughout the universe, and perhaps how it reached our planet and the moon. Scientists believe that lunar ice may have arrived here eons ago, likely carried by water-rich asteroids that impacted the moon's surface. All these factors are of colossal significance for humanity. The South Pole appears to be an ideal location for establishing a full-fledged lunar base that could house a permanent human presence. One can imagine grand brick domes connected by a complex network of hidden underground tunnels. Inside these structures, work would be bustling. Numerous specialists would be busy at computers, while others would explore the lunar landscape in specialized rovers or head out to extract valuable resources. Scientists and engineers are developing highly ambitious and innovative concepts for its construction. Probably the first thought that comes to mind is transporting bulky and heavy water-absorbing modules from Earth. However, a much more efficient approach might exist. Let's recall the history of our civilization. Every time humans explored new territories, they meticulously studied the environment in search of available resources, using them for survival and subsequent prosperity. This is how humanity spread across its entire planet, so why not apply the same principle to colonizing the moon? Now, a logical question arises. What resources can the moon offer? We are well aware of the presence of ice, which can be processed into water. However, it is obvious that our planet lacks lush vegetation and edible plants. Nevertheless, it may not be obvious, but the moon can indeed offer something valuable: mineral resources and sunlight. Unlike Earth, where the sun regularly rises and sets, the lunar poles offer a rather amazing sight. The sun gracefully moves along the horizon throughout the entire day, meaning an almost continuous source of energy can be provided. Just imagine living in a world bathed in eternal sunlight. Scientists are confident that solar panels would be thrilled with such an abundance of energy. However, we could use not only the light of the sun but also its heat. Frankly, absolutely all available resources must be utilized. If there is an excess of metal after oxygen production, that metal should also find a use. We are obliged to be environmentally responsible not only on Earth but also on the moon. Therefore, scientists are actively studying ways to convert the moon's most abundant resource, regolith, into strong building bricks. They have demonstrated a very inventive approach to creating lunar bricks. Researchers plan to use the sun's heat to melt lunar dust layer by layer, essentially creating a sort of three-dimensional printer for lunar dust. Engineers have also experimented with making bricks in solar ovens and irradiating lunar soil with microwaves. In these methods, they have achieved significant success. Thus, It is quite likely that we are going to establish a small brick factory on the moon and build houses out of regolith. It is reminiscent of the game Minecraft in real life. Once you discover some unique new material, you simply have to build a small house out of it. If successful, these bricks could be used to construct full-fledged buildings, potentially covering inflatable modules or giving new life to abandoned landers. Would astronauts then need to become skilled bricklayers? No, they wouldn't do all the work themselves. A small automated system would be required, involving robots working in close cooperation. Humans, of course, would oversee the construction site. Despite all this automation, scientists believe that life on the moon will be, shall we say, cozy. Design solutions might include multi-tiered living spaces or multifunctional zones. However, certain difficulties will inevitably arise. Extreme conditions prevail on the moon. Imagine scorching temperatures that can reach 100 degrees Celsius during the day and drop to a frosty minus 179 degrees Celsius at night. And it's not just the weather. The moon is relentlessly exposed to solar radiation, cosmic rays, and micrometeorite impacts. All these factors gradually degrade everything on its surface. Another serious problem is lunar dust. There is no breathable air on the moon, and the dust there can cause significant difficulties. And this is not just ordinary dust. It is very sticky and can even cause astronauts to sneeze and have watery eyes, as if they have lunar hay fever. It can also damage equipment and spacesuits. This is not to be trifled with. Scientists have discovered that dust forms when meteors strike the moon, creating tiny particles and sharp fragments of glass. It is toxic, and its microscopic particles can float in low lunar gravity, making breathing difficult. Unlike Earth, there is no wind or rain on the moon to clear it away. Therefore, researchers are now actively studying this problem to find out how to prevent this pesky issue from spoiling their entire mission. This lunar spot, seemingly serene and tranquil, actually holds far more unknowns than meets the eye. Researchers aim to unravel the mysteries of low-frequency electromagnetic waves. These waves represent a subtle whisper emanating from the most distant corners of boundless space. For many centuries, these elusive signals remained hidden from human perception. Until recently, we only picked up a chaotic cacophony of radio noise and other background interference, unable to grasp the essence of these cosmic messages. However, now, on the far side of the moon, a unique opportunity opens up for recording and meticulously studying them. Research into these waves will allow scientists to unveil the mysteries of the universe's origin. This is not just about Earth or its satellite, but about the possibility of looking into the very origins of our world. A new lunar laboratory has the potential to forever change our understanding of cosmic space. Thus, the National Aeronautics and Space Administration, or NASA, harbors grand plans for the moon. Their mission, named Artemis, successfully concluded with its return to Earth in December 2022, having spent almost 1 month in outer space. This spacecraft traveled significantly beyond the moon. The success of this mission demonstrated the impressive capabilities of some of the latest technological developments that will aid in future Mars exploration. The primary goal of the Artemis program is to establish a permanent human presence on the moon. As part of this program, there are plans to build a gateway, a kind of space station located in lunar orbit, which will facilitate landings. The Artemis II mission will carry astronauts to lunar orbit in 2024, and during the Artemis III mission, planned for the mid-2020s, 2 astronauts will land near the moon's south pole. It is highly probable that a full-fledged lunar base will be constructed within the next few decades, so it is advisable to stay tuned for further news and developments. It should be noted that something extremely significant will undoubtedly occur, something that could profoundly impact everything humanity has ever known about space and time. Everyone is probably aware of the existence of black holes, aren't they? These are phenomenally dense objects, typically located at the centers of galaxies. 2 such black holes, situated 9 billion light-years from Earth, are expected to collide, and frankly, no one would want to be anywhere near it at that moment. Let's be clear. Black holes are the most powerful objects known to us in the entire universe. If they decided to enact revenge of the Sith on us, humanity would be doomed. A black hole was once a massive star that exploded as a supernova, meaning the star collapsed in on itself, and the colossal force of the explosion created a black hole in its place. By the way, black holes don't suck objects in like a vacuum cleaner. That's just a common myth. Suppose we replaced our sun with a black hole at the center of the solar system. Little would change, except we would all simply freeze to death. However, black holes are capable of something far more destructive than merely absorbing matter. They can destroy the universe itself. If a black hole followed a standard timeline, it would progress from its formation to its complete disappearance. But this process is extremely slow. We are talking about billions and billions of years before a black hole completely loses its mass. This happens because they continuously lose mass every second. Black holes radiate their mass, much like a boiling kettle loses water in the form of steam. Nevertheless, events rarely unfold strictly according to plan, both in our daily lives and, evidently, in the universe. Therefore, it will not be a great surprise to learn that two black holes are on a collision course. This is precisely what scientists recently discovered, and, let's just say, it's one reason why the scientific community is experiencing a certain degree of alarm. The first question that naturally arises is, what does this mean for us, for humanity? Total annihilation? No, let's not be so dramatic. At best, we are in for an experience similar to what was depicted in the movie Interstellar. Let's backtrack a bit to understand how this could happen. 45 years ago, a group of scientists began noticing unusual behavior emanating from an extremely distant galaxy. This galaxy is located 9 billion light-years from us, and its scientific name is quite long, but let's just call it the Very Distant Galaxy. You might wonder, how did scientists observe this black hole so far away if it emits no light? That's an excellent question. The fact is that black holes gather disks of gas around them, and they eject some of this material into space. These powerful jets can be detected from millions of light-years away. If these jets of hot gas are directed straight into space, scientists give such black holes a special name: blazar. Recently, one specific blazar attracted keen attention from the scientific community. This cosmic object has a rather long name, but for simplicity, it was conditionally named Andy. Imagine the scene. A scientist from the California Institute of Technology, or Caltech, intently observes this blazar through their radio telescope and suddenly notices its highly unusual behavior. Andy's brightness flickers on and off like a ticking clock, displaying astonishing periodicity. Initially, researchers could not grasp the essence of what was happening in this distant corner of our galaxy. However, then a flash of insight struck them. Another black hole must be orbiting the main blazar. In other words, scientists concluded that another blazar, named Gomer, orbits Andy, and the regularity of their flickering may indicate that they are approaching the moment of complete collapse. The situation is exacerbated by the fact that the mass of each of these two blazars is estimated at several 100 million times the mass of our Sun. Just imagine our Sun. It is truly colossal, exceeding the mass of our Earth by 333,000 times. This means humanity is about to face a phenomenon that is far beyond our ordinary understanding and experience. Such discoveries are not entirely new to science. For example, in September 2015, the LIGO Observatory detected the collision of two black holes, each 30 times heavier than the Sun. This grand cosmic event released a colossal amount of energy, equivalent to 3 solar masses. And what is most astonishing is that this gravitational wave swept through Earth at the speed of light without having any perceptible effect on our planet. Perhaps you were asleep at the time and felt something strange in the air, but nothing significant happened either to us as a species or to our planet. However, this is explained by the relatively small power of that explosion. The crux of the problem is that the anticipated collision between Andy and Gomer is predicted to cause unprecedented gravitational waves that will sweep through galaxies and reach our solar system. But what is this shockwave capable of? In one possible scenario, it could stop our Sun's gas emission for several minutes, which, in turn, would lead to the cessation of heating in the solar system. So imagine you are enjoying your summer day, and suddenly the atmosphere freezes for a few seconds. Doesn't sound very pleasant, does it? However, this is actually a much more favorable outcome than the next one. In one of the worst-case scenarios, the explosion from the collision of Andy and Gomer could break the bonds between atoms and cause absolutely everything to disintegrate. You, I, your pet cat, we would all turn into tiny flying particles floating in the boundless vacuum of space. This may sound terrifying, but scientists remind us that an atom consists of 99% empty space. This means that everything on this Earth, all 8 billion of us, and everything that exists, planets, objects, animals, all consist of 99% empty space. Thus, perhaps all Andy and Gomer will do is simply separate all our atoms and de-solidify us, stripping us of our familiar form. On the other hand, this colossal explosion could disrupt the very fabric of space and time as we know it. You remember Albert Einstein, don't you? This genius, whose ideas once seemed crazy, is the author of the theory of relativity. Einstein discovered that time is relative. It always depends on the observer. This means that time does not flow uniformly throughout space. Why is that? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein revealed that gravity is an effect that objects have on the fabric of space-time. Every object with mass, including you, me, your cat, and our planet, creates a curvature or distortion in this fabric of space-time, causing it to bend. The greater the mass of the object, the stronger its gravitational force, and the greater the distortion of the fabric. This may seem complex, but this is precisely what creates different perceptions of space and time across the cosmos. This is why you will age differently on Earth and on Jupiter. This is why time flows completely differently for astronauts on long missions and for people remaining on Earth. And this is why the collision of two megablazars could disrupt our perception of space and time due to the immense force of their gravitational shock waves. It should not be forgotten that black holes themselves represent a colossal curvature in the fabric of space-time. Do you remember that thrilling scene from the movie Interstellar, where the protagonist distorts the space-time continuum by passing through a black hole? Just don't try to replicate that at home. As far as we know, anyone who decides to enter a black hole has no guarantee of returning. Scientists suggest that this blazer explosion will occur in approximately 10,000 years. But wait a minute. If this blazer is 9 billion light-years from Earth, that means these two black holes must have collided long before our solar system and our home planet were born. You see, the solar system was born only about 4 billion years ago. And since it takes us 9 billion light-years to receive the light emitted by the blazers, this means the collapse of the two blazers has already occurred, and it will reach Earth in 10,000 years. This means that the shock waves are already sweeping through galaxies at this very moment. But still, this is not an event that even your great-great-great-great-grandchildren will witness. Let's now break down these amazing phenomena in detail. First and foremost, the question arises, what exactly is a black hole? A black hole is a unique region of space-time where gravitational attraction reaches such incredible strength that nothing, not even the tiniest particles of light, can escape beyond its boundaries. Like a giant cosmic vacuum cleaner, it absorbs absolutely everything that dares to approach it within a critical distance. Its colossal mass is so immense that it literally warps the very fabric of space-time in its vicinity. Black holes are rightly considered some of the most terrifying and mysterious objects in the entire universe, representing a most powerful force of nature that defies existing human understanding of physical laws, embodying a true cosmic enigma. Black holes exhibit a striking variety in their sizes, from tiny objects only a few miles wide to supermassive giants whose mass exceeds the sun's by billions of times. Most of them form as a result of the catastrophic collapse of massive stars. After its birth, a black hole continuously grows in size, absorbing absolutely everything in its path. If two or more black holes collide, they can merge into a single incredibly enormous cosmic monster, performing a terrifying dance of fusion. But what about their smaller counterparts? The smallest known black holes are called stellar black holes. This type of black hole has a mass that ranges from 3 to 10 times the mass of our Sun. Being extremely small by cosmic standards, its size can be compared to compressing all the matter of the solar system into an object comparable in volume to New York City. And yes, it is indeed considered very small. For a clearer comparison, intermediate mass black holes weigh from 100 to 1,000 solar masses, while supermassive black holes reach millions or even billions of solar masses, being unimaginably huge in their dimensions. Thus, stellar black holes appear as virtually nothing compared to their larger relatives. Imagine a massive star, significantly exceeding our Sun in size, with nuclear fuel burning brightly and hotly in its heart. However, when the star runs out of this life-sustaining fuel, gravity inexorably takes over and begins to compress the star. The more intense this compression, the higher the temperature becomes, until the star's core reaches billions of degrees Celsius. Ultimately, the core collapses under the force of its own ever-increasing gravity. This process generates a colossal explosion known as a supernova. This collapse leads to the formation of a singularity, a point of infinite density and gravity. This point is surrounded by an event horizon, an invisible boundary beyond which nothing, including light, can escape. And that is how, as if by magic, a stellar black hole is born. Quite a mind-boggling spectacle, isn't it? Stellar black holes are the most common type of black holes known to us today. These cosmic objects are ubiquitous in our galaxy. In this regard, the question arises, what are the chances that such a small monster would approach our Sun, and what would happen to us in that case? In reality, the probability of the Sun colliding with any black hole is incredibly small. It is a practically impossible event. Although stellar black holes are the most common type of black holes in the universe, they are by no means an everyday occurrence. The chances of the Sun and any black hole intersecting are so rare that it can be compared to winning an intergalactic lottery. Only such a win would bring no joy. As of 2023, the closest known black hole to our solar system is named Gaia BH1. It is approximately 10 times heavier than our Sun, and even it is located about 1,600 light-years from us, which is a quadrillion miles. Thus, it can be confidently asserted that nothing threatens our Sun in the near future. However, as they say never, right? As with any significant astronomical event, we need to consider various scenarios in which this could occur. For example, such an outcome would be possible if a rogue black hole swept through our solar system, much like a comet or asteroid. Unfortunately, unlike comets and asteroids, black holes are invisible to direct observation and can only be detected by their gravitational pull. Thus, we would not see a huge, ominous black hole hurtling directly towards us. Rather, we would only become aware of its presence if it caused any perturbations in the orbits of nearby cosmic objects. So, what's next? We know that the Sun is a massive luminous star located at the very center of our solar system. It is about 4.5 billion years old, and it has enough nuclear fuel to last for approximately 5 billion more years. This star is so large that its size is difficult to even imagine. In fact, if you were to place all the planets of our solar system inside it, there would still be plenty of empty space left. And it is so massive that it contains almost 100% of the entire mass of the solar system. Therefore, it is difficult to imagine how some insignificant, small black hole, thousands of times smaller than this star, could swallow it. And you are absolutely right. It wouldn't swallow it. Well, at least not entirely. Imagine a hypothetical situation, a rogue black hole, having traversed the boundless expanses of space, suddenly invades the confines of our solar system and begins inexorably approaching the Sun. As it draws closer, the colossal gravitational force of this cosmic object will inevitably begin to pull matter from the surface of our star. The Sun, under the influence of this unimaginable tug, will begin to deform and stretch, much like an elastic material. This phenomenon is called spaghettification. One can imagine a rubber band stretching to its limit and eventually snapping. Something similar would happen to the Sun. The matter thus collected will form a swirling disk around the black hole, known as an accretion disk. As more and more material is drawn into it, this disk will begin to heat up to extreme temperatures and emit powerful radiation. And simultaneously, as the sun is absorbed, it will itself begin to release a colossal amount of energy in the form of light and heat. Our star will become significantly brighter and hotter than ever before. The sun's outer layers will then vaporize, creating a giant cloud of gas and dust that will rapidly expand in all directions. This spectacle could be compared to cosmic fireworks, but with truly terrifying consequences. Although such an event would undoubtedly be one of the grandest and most spectacular sights in the entire universe, humanity, unfortunately, would not be able to witness it. And, as one might easily guess, planet Earth would face extremely severe trials. Intense radiation and streams of solar material would trigger massive wildfires, and the unbearable heat would lead to the complete evaporation of all oceans. Earth would be under constant exposure to high-energy particle streams, and its atmosphere would be completely ionized. In other words, the chances of any life form surviving on the planet would approach absolute zero. And this catastrophic collision would have far-reaching consequences not only for Earth but for the entire solar system as a whole. Powerful radiation and unimaginable heat would vaporize absolutely everything in its path. All planets in our system would be irreversibly destroyed. The Sun, being an object significantly larger than a typical star, would not be entirely engulfed by the black hole. However, it would undergo substantial distortions and destruction. The black hole's intense gravity would tear away the Sun's outer layers, triggering a massive explosion known as a tidal disruption event. But, in any case, ultimately, the black hole would emerge victorious. It would grow in size, and a new accretion disk would form around it. As we've already established, a collision between the Sun and a black hole, regardless of its size, be it tiny or stellar, would be a truly epic and catastrophic event for our entire system. But, fortunately, as previously mentioned, the probability of such a collision is extremely low. However, this by no means implies that we should cease studying black holes and their potential impact on the universe. The more knowledge we acquire about these mysterious cosmic objects, the better equipped we will be to understand and predict their behavior. Therefore, let us continue our research, explore, and observe the depths of space, and who knows, perhaps one day we will indeed discover a black hole that proves too curious and approaches the Sun too closely. Let us sincerely hope that by then humanity will already be inhabiting other, distant planets. The universe is a vast, mysterious, and constantly changing space. But just as each of us has childhood photos capturing our appearance in our youth, scientists also have a kind of baby picture of the universe. Only they managed to look 14 billion years into the past. How was this possible? Let's delve into this question in detail. Imagine winning a scientific award comparable to an Oscar for a picture that shows the entire universe in its infancy. Scientists achieved this fantastic feat using NASA's Wilkinson Microwave Anisotropy Probe, WMAP, to obtain this image. They designed and built a state-of-the-art satellite, launched it into outer space, and collected a colossal amount of data about the universe. This image turned out to be a true cosmic treasure trove. It helped answer some of the greatest questions about the universe, but also unveiled several new, previously unknown mysteries. This groundbreaking data confirmed the standard model of cosmology and informed us that our universe is approximately 13.7 billion years old. Furthermore, it clearly demonstrated that the elements of our ordinary periodic table constitute only a tiny fraction of the universe's entire recipe. To be honest, it's not exactly a photograph in the usual sense of the word. Of course, we cannot take a snapshot of something that happened so long ago. The image in question is called the cosmic microwave background, or CMB for short. The cosmic microwave background is like a faint, barely perceptible glow that uniformly fills the entire universe in all directions. This indirect data can help us understand how the universe evolved to the state it is in today. The CMB is an incredibly cool glow that permeates the entire universe. You see, when you look through an ordinary telescope, the space between stars and galaxies appears completely dark. But with an amazing radio telescope, we can actually detect that this seemingly empty dark space is filled with a very faint and surprisingly even glow. This glow surrounds us everywhere, and it does not emanate from any specific star or galaxy. This is the cosmic microwave background, and it is most intense in the microwave part of the radio spectrum. The cosmic microwave background, or CMB for short, appears before us as a truly frozen treasure, enveloped in supercold, with a temperature reaching approximately -454 degrees Fahrenheit, which is equivalent to -270 degrees Celsius. This, without a doubt, surpasses in its severity any winter ever experienced by humanity. This ancient light, like a message from the distant past, originated approximately 380,000 years after that grand event we call the Big Bang, which occurred about 14 billion years ago. Thus, by observing the CMB, we are effectively looking far into the depths of cosmic history. In its infancy, the universe resembled a dense, impenetrable fog consisting of incredibly hot plasma. Its temperature then reached almost 500 million degrees Fahrenheit. The heat was so intense that atoms in their usual form could not yet be created. There existed only chaotically moving, as if mad, wild electrons and protons. Due to this super-hot, dense veil, any light that tried to penetrate it was immediately scattered by these elusive, mischievous electrons. This can be compared to attempting to see anything through a heavily fogged car windshield. However, the universe then began to expand in all directions, like a giant cosmic balloon, constantly increasing in size, and this process of expansion continues to this day. As the universe underwent this continuous expansion, it gradually began to cool. When it reached an age of 380,000 years, the temperature finally dropped to a level sufficient for electrons and protons to combine. These tiny particles began to clump together, primarily forming hydrogen atoms. The moment this occurred, the universe finally became transparent, like absolutely clear window glass. The moment of this truly magical transition was named the Epoch of Recombination. Once the foggy era concluded, light gained complete freedom to move. The universe transformed into a vast playground for light, where it could travel and explore unimpeded. And, as is well known, light possesses a certain speed, 186,000 miles per second, or about 300,000 kilometers per second, to be precise. And light emanating from distant corners of the cosmos requires a significant amount of time to reach us. Thus, in other words, the cosmic microwave background is the oldest light in the universe. It is like a snapshot capturing the very moment when the universe just began to become clear and transparent. As this light traveled through space, it experienced all sorts of adventures, including the formation of stars and galaxies. Along the way, it lost some of its original energy and transformed into microwaves, which are invisible to human sight and can only be detected with special instruments. Additionally, there are certain complex factors that can distort the obtained data. For example, galaxy clusters. These are enormous groups of galaxies that gather together in cosmic space. When the ancient light from the CMB travels through the universe, it encounters these groups, and these clever clusters try to leave their mark on the CMB. They distort the patterns in the ancient glow, as if smudging ink in an important ancient book. This is why scientists have to develop complex methods and apply supercomputers to help clean up this mess and correctly decipher everything. Because of all these factors, the cosmic microwave background is not perfectly uniform. It possesses small irregularities and unique patterns. These peculiar patterns make it unique, a kind of fingerprint of the universe. Scientists use amazing tools such as the Cosmic Background Explorer, COBE, and the Wilkinson Microwave Anisotropy Probe, WMAP, to study these patterns. The Cosmic Background Explorer, which can be figuratively called our cosmic camera, created the first ever map of the sky in the microwave range between 1989 and 1993. Why do we study it? Well, because the cosmic microwave background can help us learn so much about the early universe, how it expanded, how much ordinary matter and mysterious dark matter it contained, and even the overall shape of the universe, among many other things. We are, essentially, playing detectives with the cosmos, trying to unravel the mysteries of our world from small clues and imprints. What are the results? Well, amazing tools like the Wilkinson microwave anisotropy probe have helped us learn even more incredible facts. For example, we found out that we can actually only see 5% of the universe. Imagine the universe as a cosmic pie. Scientists have learned that 68% of it consists of something called dark energy, and 27% is dark matter. Only a tiny 5% consists of ordinary matter that we, humans, can see. So, most of the universe is a kind of hidden realm that we cannot even imagine. We have also grasped the mysteries of what happened at the dawn of time. Imagine the universe immediately after the Big Bang. It was incredibly tiny, significantly smaller than a proton. Absolutely everything we observe today was compressed into this minuscule volume. Back then, the laws of quantum mechanics reigned supreme, allowing the most incredible and whimsical events to occur. Matter and energy behaved like mischievous adventurers, at times borrowing something from the future, at others disappearing without a trace. Then came cosmic inflation, and the universe suddenly expanded, like popcorn popping, but on a grand cosmic scale. It became a trillion times its original size, generating waves of gravitational chaos everywhere. Some of these gravitational waves filled the young universe, like a boundless sea, and their unique patterns left indelible imprints on the light of the cosmic microwave background. And all these amazing discoveries were made possible by the images of the cosmic microwave background. By the way, the National Aeronautics and Space Administration, NASA, has developed an amazing plan to study the universe's baby picture. They are going to utilize an advanced observatory called PIPER, which stands for Primordial Inflation Polarization Explorer. Imagine PIPER as a special cosmic balloon that will ascend high into the sky from a location called Fort Sumner, New Mexico. On board are two powerful telescopes enclosed in a jacuzzi-sized container filled with liquid helium. This liquid helium is incredibly cold, with a temperature of about -452 degrees Fahrenheit or -269 degrees Celsius. However, PIPER loves the cold because it is precisely thanks to it that it possesses exceptional sensitivity. What is its main mission? To learn absolutely everything about the early days of the universe by studying its very first baby picture. From its position, PIPER will meticulously examine the cosmic microwave background, striving to detect hidden patterns that hold the secrets of how the universe grew and transformed over time. This cosmic detective with a magnifying glass will explore 85% of the celestial sphere. PIPER's launch is scheduled for late September. You can even watch the thrilling process of the balloon being filled live on the Columbia Scientific Balloon Facility website. It will truly be out of this world. Thus, the cosmic microwave background acts as a time-traveling storyteller, providing us with invaluable clues to the universe's incredible past. Isn't that amazing? The cosmos is full of amazing surprises, and we have so much more to discover. Keep your eyes on the stars, and who knows what else we'll find there. Saturn's famous rings will disappear in less than 2 years. Soon, we won't be able to observe Jupiter's great red spot. Pluto's atmosphere could vanish any day. Even the universe itself may be slowly evaporating right now. But let me begin the narrative from the very beginning. Saturn's rings won't disappear forever, at least not in the near future, but they will seemingly vanish from sight. This phenomenon is due to the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will become invisible to stargazers in 2025. This striking disappearance occurs because Saturn's thin rings turn edge-on. It's akin to holding a sheet of paper horizontally at eye level, parallel to the ground, so only the edge of the paper would be visible. Something similar happens with the gas giant's rings as the planet's seasons change. Instead of the south side of the rings tilted towards us, we begin to see the north side. But then the planet tilts back, revealing the south side again. This ring plane crossing occurs every 15 years when our planet passes through the plane of the gas giant's rings. The last time this phenomenon was observed was in 2009. After that, the rings gradually became visible again over several months. This time, the rings will be edge-on in March 2025. They will then slowly reappear and disappear again in November of the same year. Soon after, the rings will reappear again, first becoming visible to the largest telescopes, then to everyone else. At the same time, in the more distant future, the rings may disappear permanently. Astronomers have concluded that Saturn's rings, which are mainly composed of ice and rocky dust from shattered asteroids, are younger than we previously assumed. They are constantly losing tons and tons of mass per second, and it is likely that no more than a few 100 million years will pass before they completely disappear. Let's move on to the Great Red Spot, Jupiter's grand atmospheric vortex. This colossal, unceasing storm is predicted to cease its rotation within the next 20 years. This storm exceeds our planet in size. It was first recorded in 1830, but mentions of a giant spot on Jupiter also appear in observations from the 1600s. If we assume that we are talking about the same Great Red Spot, then it can be said with certainty that this storm has raged for many centuries. The power of this vortex was sustained by Jupiter's jet streams, which varied in speed from 300 to 400 miles per hour. Nevertheless, like any other atmospheric phenomenon, the Great Red Spot cannot exist forever. For a long time, it has steadily decreased in size. In 10 or 20 years, according to predictions, it will transform into a so-called GRC, or Great Red Circle, and then perhaps into a GRM, Great Red Memory, becoming merely a remembrance of its former grandeur. In the late 1800s, the diameter of this storm exceeded 35,000 miles, which is 4 times the diameter of Earth. But when the Voyager 2 spacecraft made a flyby of Jupiter in 1979, the storm had already shrunk by almost half its original size, and this reduction continues to this day. In 2017, the GRS's width was just over 10,150 miles, which is less than 1.3 times Earth's diameter. Next, Pluto's atmosphere is undergoing an unusual transformation. This icy dwarf planet, located more than 3 billion miles from Earth in the Kuiper Belt region, attracted keen attention from astronomers in 2018 when it passed in front of one of the stars. Thanks to such a powerful light source illuminating Pluto, researchers were able to study the dwarf planet and its atmosphere in detail. They came to the striking conclusion that Pluto's atmosphere is refreezing onto its surface as the dwarf planet becomes colder and colder. Astronomers used several telescopes located at various points in the USA and Mexico to observe Pluto and its thin atmosphere, which mainly consists of nitrogen. This atmosphere is maintained by the vapor pressure of ice on the dwarf planet's surface. For about 25 years, Pluto has been moving away from the Sun, and its surface temperature is gradually decreasing. Pluto is currently at a significant distance from our star, but at some point, it will begin to approach it again in other regions of its incredibly vast orbit. In addition to Jupiter's Great Red Spot, Saturn's rings, and Pluto's atmosphere, humanity is also facing the phenomenon of disappearing stars. But stars can't simply vanish, can they? For many millennia, scientists were convinced that heavenly bodies remained motionless and unchanging. Even after they realized that these luminaries were physical objects similar to the Sun, they were still sure that stars underwent serious changes extremely slowly, on scales of millions and billions of years. In reality, the most massive stars, which can be hundreds of times heavier than the Sun, are capable of experiencing sudden catastrophic events. For example, upon reaching the end of their life cycle, they die in dazzling supernova explosions, shining for months and remaining visible from hundreds of millions of light years away. However, there are stars that seem to simply dim without apparent reason. This appears impossible, and for the past several years, a group of researchers has been actively trying to determine if such a phenomenon is actually possible. They began a meticulous comparison of data collected over decades of observations. The project was named VASCO, Vanishing and Appearing Sources During a Century of Observations. Scientists are interested in all kinds of disappearing objects, but they especially hope to find a star that was stable and present in the sky for a long time, and then simply vanished without a trace. Even if a super-powerful telescope is pointed there, nothing will be visible. Our current understanding of the cosmos and its fundamental laws suggests that stars change very slowly over prolonged periods. Dramatic disappearances should leave noticeable traces. Of course, this does not mean that all stars must shine stably. The night sky is filled with stars that change their brightness and pulsate. But VASCO is something entirely different. Scientists seek to find an object that transforms from a completely stable star into a completely vanishing one. Such a phenomenon has not yet been documented, and such a discovery could lead to the creation of new physics. Now, we must turn to the most exciting topic, the phenomenon of the evaporating universe. According to the widely known theory developed by the distinguished Stephen Hawking, black holes, being the densest objects in space, are subject to a process of evaporation over time. They lose their mass, transforming it into a unique radiation. However, the latest research suggests that Hawking radiation, or something very similar to it, may not be the exclusive prerogative of black holes. In all likelihood, it is present everywhere, which could mean the gradual but relentless evaporation of the universe right before our eyes. Hawking radiation is a phenomenon that has not yet been directly detected, but numerous theoretical constructs and experimental models point to its potential existence. Let's consider how this supposedly functions. There's a common misconception that black holes are cosmic vacuum cleaners that attract everything that happens to be in their immediate vicinity through their colossal gravitational influence. In reality, black holes do not possess more gravity than any other cosmic object of similar mass. Their distinctive feature is exceptional density, an incredible amount of mass concentrated in an extremely small, tiny space. In a certain zone adjacent to such a dense object, the gravitational pull becomes so all-consuming that the possibility of escaping it disappears. Even the speed of light in a vacuum, which is the fastest known phenomenon in the universe, proves insufficient. Simultaneously, any sufficiently massive or dense object is capable of causing significant space-time curvature. Simply put, the grand gravitational field of these objects forces space-time to bend around them. Although black holes serve as the most prominent example of this phenomenon, space-time is also subjected to curvature around other superdense objects, such as white dwarfs, neutron stars, or giant galaxy clusters. This implies that any superdense and supermassive object could potentially generate some radiation similar to Hawking radiation. And over a very, very long period of time, this could lead to the complete evaporation of everything in the universe, mirroring the fate of ancient supermassive black holes. If this hypothesis is confirmed, it will radically change our understanding not only of the nature of Hawking radiation, but also our overall view of the universe, its future fate, and our own future. Thanks for watching, friends. Don't forget to subscribe to the channel